Okay, good morning, everybody. Here's Leonardo Militano from University of Applied Science in Zurich, in Switzerland. I will be presenting to you some research activity I've done in our research group, and the title is Accelerating Data Computation on Ceph Objects. First of all, let me thank the organizers for inviting me to this important meetup and to present our results. So the agenda of my presentation is as follows. Slides go, yeah, is as follows. I will first of all give a brief introduction to the cloud storage concepts we are active on in our research group, and to give a bit of a context of the presentation I'm giving right now. And from there, I will give some hints or some solutions about data analytics based on data locality. And in particular, I will focus on two approaches that we have been investigating lately. And from there, I will reach to the main focus of this presentation, which is the test we have made using Alluxio for data analytics, and those results will be presented later on. In particular, I will focus on performance evaluation in specific scenarios, and this will be presented and compared to classic Ceph based approaches where you retrieve the data from the backend storage. And then at the end, I will draw some conclusions about our results. But first of all, let me briefly introduce a bit more the research group I'm part of and our university. So as I said, I'm part of the Zurich University of Applied Science in Switzerland, and in particular I'm part of the service engineering group. I'm here as senior researcher, which means I'm participating both in teaching and also in the research activities. The core expertise of our group are historically everything that covers the cloud system, so infrastructure as a service, platform as a service, and software as a service, and everything related to virtualization. And the focus is mainly on scalable and reliable implementation of IT-based services. How we are organized is we have several research initiatives. I would mention the main two at the moment are cloud, so everything that is in cloud, so infrastructure, platform, until cloud native applications lately. But we're also very active on robotics, but not pure robotics, but cloud robotics. So we investigated the ROS operating system for cloud robotics. You can find more details about our research topics and activities on a blog post. Here I share the link in this slide. It's actually through this blog post that I somehow got in contact with people from Alluxio that saw a blog post about our research activities using Alluxio, and then that was the starting of how I came here to present my results. As a research institute, as a university, of course, our research agenda is based on core research expertise, and this is so the foundation of our activities based on research projects. On research labs and teams. We have different labs and teams within the main core focus of our group, and also we have strategic collaborations. These are both with universities, other research institutes, and companies, both at the national level and also international level. So mainly European, in the European area. All these activities will produce some impact mainly in four pillars. We strategically divided in four pillars. Of course, we do publications of our results on research papers and also blogs. We have contributions on standards. We have contributions on open source projects and software products. And we also have some internal lab products that we then, all these four pillars will be used to perform some technological transfer and consultation to SMEs. But everything that happens within these three main activities is then conveyed somehow to the educational part of our institute, because we have bachelor and master students in computer science that will benefit of our know-how that we built through these activities. Having this said, the presentation falls within the research activities on cloud storage in general. Before going a bit deeper about the topic itself, I like to give some numbers. I always like to give some numbers to set a bit of a context of where we are with cloud storage today and what are the trends on the market and in the research. So I take here some numbers from IDC and also other research works in that can be found, and that say that the market analysis, the global storage market has an amazing annual growth of about 26%, and this is predicted to reach a huge number, which is 75 billion within the end of next year. At the same time, not only the market is increasing, but also what is tremendously increasing is the demand for data storage in general. So IDC expects that this to grow of 61% and reaching in five years. So in 2025, the incredible the number of data is of 163 zettabytes. What is particularly interesting for us as a cloud computing research group is that half of this data is expected to be stored in public cloud environments. So on one side, of course, there is an increasing demand of data storage in general, but half of this data is going to be stored on the public cloud. Another aspect that I like to underline, and another trend that we observe both in the industry and in the research, is that there is a kind of a paradigm shift where more data is created and stored and processed at the edge of the network. So on one side, again, as I said, there is a public cloud that is gaining importance, but also the edge of the network is gaining importance because the data is produced there, it is stored there, and it's also processed there. The third main aspect I want to introduce here is, as you see the second picture here, figure here in the slide on the below corner is a picture probably most of you know is taken from The Economist, where they claim there that the world's most valuable resource is no longer oil, but it's data. And this is actually already happening with big companies like Facebook, Google, and Amazon. They are using the huge amount of data that is produced and is stored in their data centers to make money out of it, selling information that can be used based on the data they collect. So this introduces this last aspect introduces a bit more into the data analytics aspect. So if data, we can say, is the new oil, this data needs to be processed into higher order products so that we can benefit of its value. So we cannot use the data as it is, as a raw material. We need to process it so that we can benefit of the value that is inside them, so the information that's inside the data itself. And there is where data analytics appears as an important aspect. Historically, what happens, so we have storage clusters, we have computation clusters. These two are typically, these entities are typically disaggregated historically, and the motivation for this was on one side because of cost efficiency, and the other aspect is better manageability of the two elements. So storage on one side and computation on the other side. This is correct. We can say this is correct as an observation. What happens as a consequence of this disaggregation is that data in general is remote, is to the compute nodes, which means that if you have to compute, so extract some information from a data that is stored somewhere, you have first to fetch the data, move it to the computation cluster, do the computation, do your analytics, and then maybe push back the data or the results to the storage cluster. This has influences, of course, on the latency. It has also influences on the bandwidth, because you are sending data over the wireless over the network access, which is typically wireless access, and also on the core network. but you're also consuming more power, you're introducing more cost, and also you have a security aspect that needs to be considered because you're sending your raw data over networks and into another cluster, so a computation cluster. So from this observation, we found out, or not only we, it's a trend in the research activities, that probably there are scenarios where a different approach is also of interest. And in particular, one approach is to bring the code to the data instead of having them disaggregated. And this is an approach that is currently very active in storage scenarios and storage standardization like SNIA, where they're pushing computational storage activities where the new storage devices have also more computational power so that the computation can be done directly on the storage device itself. And the other approach, which is a bit more the focus of this presentation, is bringing the data closer to the code. And for instance, here comes everything related to caching and in particular in-memory computation. And of course, if you do this, the common point of these two approaches is that data locality. Data is close to the computation, and you have benefits again on bandwidth, power consumption, cost, latency, and security. So this slide is just to set a bit the context of this work a bit more. We our lab have experience on working on Ceph storage. Ceph is well known as an open source unified distributed storage system, which has several very interesting features like self-management and healing. But there's an offering of the whole spectrum of storage, so object storage, block storage, and file storage. This makes it very interesting. And if we think at the first approach, so bringing the code to the data, as I was mentioning in the previous slide, we have done some analysis also on these aspects. If you follow the link here in this slide, you can find a blog post where we are showing that using Ceph object classes, you can define some specific class to make some computation directly on the storage device, on the OSDs as they are called in Ceph. And we show that in comparison to do it remotely, so fetching the data that is in the backend Ceph storage, bring it into a computation or to do some computation and then push back the result. Instead of doing this, if we do the computation directly on the storage node, we have really I think it was about 98% of time saving. So this is a very interesting aspect. The other aspect, as I was saying, is bringing the data close to the code is the second approach. So in memory computation, and here we came to Alluxio. Doing our researches, we found out that Alluxio exists, and the description of Alluxio was very promising for memory speed computation. Allows for in-memory computation and fast data analysis. This really was interesting. We studied some materials online already, can be found online on the Alluxio website. And we wanted to repeat a bit of this analysis in our context, on our own Ceph implementation and Ceph cluster. So what we did, we prepared a framework for testing Alluxio in our lab. So we had a storage cluster on one side. If you see, as presented in this figure, this was made built like with 6 OpenStack VMs. One of these was a Ceph monitor. We had 3 OSDs for the storage, 1 Rados gateway for object storage, and 1 administration node. And you can find more details on this on our blog post, but the main aspect that is in features here is that the total storage size was of 420 gigabytes over 7 OSD volumes. We had a computation cluster on the left side in the figure here. This was based on Alluxio. So we started using Alluxio version 2.3. Later on, we were able to test also version 2.4, and I will show both of the results we obtained. On top of Alluxio, Spark Apache was running in the version 3.0.0, and on Spark we had a Scala application that was running for performing some data analytics. What exactly this Scala application was doing, it is specifically accessing a text file, is counting the lines over the file, and then giving out the the amount of lines that was found in the file. This Scala application was run over Spark, and it was either run on Alluxio or directly towards the backend storage that was Ceph. So as it concerns Alluxio, we tested two cluster configuration. The first one is the very simple one with single nodes. So we had one VM. In particular, it had 16 virtual CPUs, and this was used both for Alluxio and for Spark. And for both of them, 40 GB of memory was allocated for the worker node. Later on, we tested a bit more complex scenario, cluster mode, still a smaller cluster, but we had, in addition to the master node, we had two worker nodes with the same configuration, so 16 virtual CPUs and 40 GB of memory. And we compared the results of the two cases. The important point I want to underline is that we found out, and also results will show, that this is the use of Alluxio is specifically of high interest when you have a repeated access to the same text file. So talking more broadly, if you're going to do data analytics multiple times on the same raw data, then Alluxio, from what we found out from the results and the tests we did, is very interesting and brings very high performance improvements. So in general, the comparison we made was in terms of overall execution time, and we compared different file sizes, text files. In particular, it was 1 GB, 5 GB, and 10 GB of file. And we compared, the main comparison was an Alluxio-based approach in comparison to a direct Ceph access to the text file. So in the next couple of slides, I will show the results that we obtained. The first group of results is about single VM setup results. And what we want to show here are mainly two aspects. First, as I said, when Alluxio is of interest is in particular when we have a repeated access. So what we tested is, of course, the Ceph direct access through Spark, where the Scala application was running, and we did then turn off all the applications and repeat a second time. So the whole application was restarted, and as of course it is expected, nothing changes there. So if you see the yellow histogram here and the green histogram are in all cases the same. This means that if you start on Ceph fetching an object, fetching a text file, and do the computation there, then turn off everything, repeat the same procedure, there is no difference in execution time. This is not the same. This is not true when you use Alluxio-based approach. If you compare, for instance, the blue histograms and the red histograms, we see in all cases that the red histogram is incredibly lower than the blue histogram. And so that means that when you restart the application a second time, the execution time of our application was drastically reduced. The second aspect we show is also in the same run of the application, when you access the second time the same file here, so first access compared to second access, everything that runs on Alluxio has an incredibly advantage in terms of execution time. Why is this? The main motivation of this is that the first time Alluxio is going on the backend storage on Ceph, we configured Ceph as a backend storage. He fetches the data, he brings it up in memory. The data is stored in memory, and then the computation is made. So the results of the first time the file is accessed, so the blue histogram here, are almost in line, let's say, with the Ceph approach. A bit higher, we observed the motivation for this. We explained it as because you have to store the data also in memory, and this is encountered in this execution time. But the second time, the data is already in memory. So the file is already in memory, either in the second access, or if you start the whole application, the whole Alluxio cluster, the data, the object will be already in memory, and then you can directly execute the computation in memory. And that's why we have, if you see, look at these red arrows here, are pointing at the huge improvement we observed in execution time. So I jumped from from single VM setup results to cluster setup results, the observations are the same, I would say, in general. What we observe, if you look at the absolute values here in execution time, of course, are reduced, and in general are more or less reduced by 1/3. And this is because now we have 3 nodes that are working on the computation and they're sharing the burden of the work. As a consequence of this, of course, since we kept the size of the files the same, so it's still 1 GB, 5 GB, and 10 GB of file, the advantage, the gains are a bit reduced because the absolute values are a bit reduced. If you compare, let's say here, in the single VM setup results, we reach up to 1200 seconds in the worst case, and here we have 400 seconds in the worst case. So let's say the absolute values are reduced for all cases, so also the gains are reduced. But the observations we made in terms of second access and repeated access are the same, are still valid. So the conclusions we draw from this first set of results are that both in the single node setup and the cluster mode setup, we have incredibly advantages on using Alluxio. In particular, I can mention a couple of numbers. We have up to 70 times more for 1 GB of files, until over 110 times more faster computation for the 5 and 10 GB file. The same for the cluster mode setup, but they are a bit reduced. Everything looked very nice, everything looked very good, but then more or less by chance we found out that there is something that is worth mentioning here, and it is the last point here and bullet point on this slide. So all the results we showed so far are obtained using Java version 8, and this was done because it was a prerequisite of Alluxio version 2.3. Then by chance, I installed a VM, and the default version of Java when you install it is Java version 11. And then when you look at the direct access execution time, direct access on Ceph, so Spark to Ceph using Java 11, this performed much better. And actually, when you then compare this to the results I just showed using Java 8, I found out that it was actually no gain in using Alluxio, and this was for me very surprising. It was, of course, I was doubting about some configuration I made. I tested again and again, but then I found out that really this lies in the difference between Java 11 and Java 8. After that, we were able to test Alluxio version 2.4. And one of the main novelties of Alluxio 2.4 is the support of Java 11. It was not even released yet, but we could test it on the same setting we had. So we repeated the same test again using Alluxio 2.4. The results are here in the slide. So the whole configuration, everything is the same. The whole setup is the same. It's here in the cluster mode setup. The first observation we have to do, if you look on the absolute values of the execution time, we are now not even reaching 90 seconds. If you remember the first results, we had up to 1200 seconds. This is an effect of Java 11. Using Java 11 drastically reduced all the execution time because it's performing much better. If you then compare, we then compare the results using Alluxio and not using Alluxio, there is still some benefit. As we point out here in the red arrows, there is still some benefit, but it is not so incredibly high as it was before. Motivation for this is, of course, if we keep the same configuration in terms of file size, and Java 11 brings down all the execution time, it brings it all for all the configurations, and then the gain is not so the gain is in percentage not so high. So what we concluded looking at these results is that the benefits are downscaled, and this is by the general reduced execution time that we obtained using Java 11. But still, a 6 times better performance was obtained in the largest, in the case of the largest file. So with 10 GB file, when you access the second time the same file. So this made also us make this observation that, of course, if you then take larger files, larger than 10 GB of file, then you will observe again a an increasing gain of when using Alluxio as a consequence of in-memory data analytics. So then after we did perform these results and published the blog post, I saw that on October 21st, it is officially released, Alluxio 2.4. This is nice from our perspective because this resolves really an important limitation that we found in Alluxio 2.4 in previous versions. So as a conclusion from our analysis and a conclusion of this journal talk, I would say that Alluxio enables memory space data access in those cases where repeated access to the same raw data is to be performed, because it eliminates the remote data reads, the repeated remote data reads. So if we don't keep them disaggregated completely, as I was mentioning in the first slides, computation and storage are not completely disaggregated, but we move the data closer to the computation. And if this is valid, is introducing important benefits, especially when you have to access the same data repeatedly. The results we presented show both in the single node and the cluster mode setups several order of improvements. And the further conclusion, or the further conclusion I want to make here is that, of course, Alluxio 2.3 was showing nice results, but these were good only when you were using Java version 8 in both configurations. So both if you use Alluxio and if you use direct access to Ceph using Spark. This limitation was removed with Alluxio 2.4 as this supports now Java 11, and this is, in my point of view, is fundamental to keep the performance improvements with respect to direct backend storage access. So this concludes my presentation. Thank you for joining us on this presentation and for your attention. I'm open now for questions if there are questions now. And in any case, here you see my name and my email address. If you have further questions or comments or any further curiosity, just you can reach out to me over email or over any other channel you would like to use for talking to me. Thank you very much.
Thank you so much for Leonardo's presentation. This is a very great talk. I really enjoy it. One minor question. So, Leonardo, I'm wondering, like, do you have any theory, like, why Java 11 brings so much value to the like Spark performance?
Honestly, I didn't investigate it too much in the sense that what I investigated for the results I made is really finding out if my results were correct, if the configuration was correct, because as I said, I just started with a new VM, and if you install Java and before installing Alluxio, then it installs the Java version 11, and then I installed Spark and did direct access to the Ceph, and I looked at the numbers and I thought, okay, here's something wrong. I looked more at my setup if this was wrong. I'm not sure what the main difference is between Java 11 and Java 8 in connection with Spark. Personally, I don't know this.
I see. Yeah, so in the past, when we were talking to different users, a lot of people were talking about, oh, in Java 11, you have a better GC support using the G1 GC, which might contribute to some, like, maybe performance gain here. I don't know, like, but like that's really we see a huge performance jump here. It's quite amazing. See how much advantage we can get with Java 11, but also like that's one of the main motivation for us to upgrade to Java 11, which is to be compliant with Spark 3 and like, for example, Presto.
Yeah.
Cool. This is really, I really like your talk. Yeah. If anyone have questions, you can just follow up with Leonardo on the email here, and we also have a Slack channel. If you have any questions regarding Alluxio or using Ceph with Alluxio, feel free to go to our Slack channel and talk to us. Thank you so much and enjoy your day.
Thank you.
Thank you.